Alright, so welcome back for our last logic section, section 8.2, in which we're going to learn how to do proofs within predicate logic. Doing proofs in predicate logic is pretty much the same as it was in propositional logic. You're going to have the same basic rules, modus ponens, modus tollens, hypothetical syllogism, all that fun stuff. But because we do have these quantifiers, the universal quantifier, the x, the existential quantifier, the backwards e with the x, we are going to have to add 4 additional rules into it because those rules that you learned last time, your basic rules of implication and rules of replacement, you can't use those with those quantifiers. So, the first rule we're going to look at is called universal instantiation. Basically, if you have a universal claim, basically an A or an I type statement, you're going to get rid of the quantifier and you're going to replace the x with some other letter. Now, if you're working a problem, which we'll do later, then that'll pretty much give you a good indication of which letter you want to replace it with. But for here, for these purposes, we just use some random ones for you. So if you have the universal quantifier of x, ax, then bx, then to do a universal instantiation, which is abbreviated UI, you just get rid of the quantifier and you replace the x with another letter. So an, then bn, for example. The same thing with the universal negative. You have the universal quantifier x, ax, then not bx. Get rid of that universal quantifier and replace the x with another letter. So in this case, for example, ap, then not bp. To do a universal generalization, UG, it's just the opposite. In this case, you've got the basic letters here, and you're going to get rid of those and replace them with the x and add the universal quantifier. So for example, if what you have is AR then BR, to do a universal generalization, you're going to add the universal quantifier, the x, and then replace the r with the x. So for every x, if x is an A, then x is a B. And the same thing again with the universal negative. If you have, for example, AS, then not BS, to make a universal generalization, you're going to add the universal quantifier, the x, and you'll replace the letter, the s, with x. So you'd have, for every x, if A is an x, then x is not a B. With the existentials, we basically have the same thing, the existential quantifier being the backwards e with the x. So an existential instantiation, summarized as EI, for this particular x is both an A and a B. Well, if we want to be able to work with that, we're going to have to get rid of the quantifier and replace the x with some other letter. So for example, here we're going to get rid of the quantifier, the backwards e with the x, and we're going to replace the x, in this case, with a c. All right? So ax and bx becomes ac and bc. Same thing for the negative. For this particular x is an A, but x is not a B. So I'm going to get rid of the existential quantifier, replace the x with some other letter. In this case, I use D, so AD and not BD. And then existential generalization, EG, is working back the other direction. So if I have, for example, the letter AF and BF, and I want to do a existential generalization, I'm going to add the existential quantifier and replace the basic letter, in this case F, with the X. Okay? And same thing again with the negative, AG and not BG. If I wanted to do make an existential generalization, we'll add the existential quantifier and then replace the G with the X. So you'd have, for this particular x is an A, but x is not a B. All right? So we're going to be using, in proofs of predicate logic, universal instantiation and generalization, existential instantiation and generalization. Now, one important thing for you to remember, and that is that in this form of logic, your quantifier letters, I use X most of the time, but in your book you will see also that X, Y, and Z. Those particular letters are the ones that are used in terms of your generalizations. The instantiations can use any other letter. So you can't, in doing, for example, a universal instantiation, you can't just get rid of the X, the quantifier, and make it AX then BX, because that's still a variable. So X, Y, and Z are always variables. But any other letter is going to be okay. So over here I've got a very easy argument presented, and so we just want to work up a proof of it. So we have at line 1, for every X, if X is an E, then X is an S. Line 2, we have EP, therefore the conclusion we want to reach is SP. Well, since the letter that's being used here is P, that tells me that when we do the instantiation of the first line, we're going to want to use P. So on line 3, the first thing you'd have to do, get rid of, before you can do any of the other stuff, get rid of that quantifier. So universal instantiation is going to be used here. So this is going to be made to look like that. So universal instantiation, I'm going to get rid of that universal quantifier, and I'm going to replace the X with a P. So we end up with EP, then SP, from line 1 through universal instantiation. And then we have a very simple modus ponens here. If EP, then SP, EP, therefore SP, from 2 and 3, modus ponens. Okay? So basically, like I said, other than using the instantiations and generalizations, working a proof in propositional logic is pretty much the same as it was in terms of other forms. So let's look at another one here. For every X, AX, then CX. For number 2, for this particular X, AX and GX. Therefore, for this particular X, GX and CX. Okay. So now with this one, there isn't any specific letter that's being given to us, so we can just arbitrarily choose any letter that we want to. I'm going to make it N. Sounds good. So for line 3, I'm going to take line 1 and do a universal instantiation. Get rid of that universal quantifier. We make this AN, then CN from line 1, universal instantiation. Then line 4, I'm going to do a existential instantiation on line 2, using again that same letter. So I'm going to get rid of the existential quantifier, and we make that AN and GN from line 2, existential instantiation. And from there, we just go on and solve it as we normally would. I would take line 4, AN and GN, use simplification to make that AN, and then lines 3 and 5 make a modus ponens. If AN, then CN, AN, therefore CN. Right, so 3 and 5 modus ponens. Now we're trying to get to what's basically going to be GN and CN. So I need GN, I've already got the CN. So back on line 4, AN and GN, we can simplify the other way and make that GN from line 4 through simplification. And now you've got the GN and the CN on 2 lines. We're going to use conjunction to stick those together. So Gn and Cn from 6 and 7 through conjunction. And now, it wants it in this form, so now we're going to take this and we're going to do a existential generalization, where we take the basic letter and we replace it with the variable. So we want to end up with the backwards EX, which is an existential generalization. So we'll add the quantifier, really eliminate the n's, and replace them with the x's. And that was from line 8 through an existential generalization. Okay, so really that's all there is to it. It's the basic rules, the basic ideas here. Let's take a look on page 473. We have 8.2. And in these exercises, you're given some basic predicate logic arguments, and you're supposed to use these rules along with the other 18 to try to solve them. I want to take a look with you at number 7. I know that's odd, but number 7 has something important to show you, which I've already alluded to, but it is something that is worth noting. So number 7 on there, line 1 says x, jx, then kx and lx. Line 2 says EY, not KY. Therefore, EZ, not JZ. I wanted to show you this one because it is deliberately put there to try to trick you. The basic idea here is that we have the variable x, y, and z all within the same equation. And it makes it look like it should be something very, very difficult. But here's the thing that you need to remember, is that there is absolutely no rule whatsoever that says that you cannot use the same letter in instantiation for x, y, and z. So because they're variables, you can replace them with any of the other letters of the alphabet you want to. So I'm going to replace x, y, and z all, let's say, with the letter P. So for line 3, I'm going to take 1 and I'm going to do a universal instantiation. That becomes JP, then KP, and LP from 1 universal instantiation. Then on line 2, I'll do an existential instantiation and make that not KP. All right. Now, you simply go about the process of solving it. I would take line 3, JP, then KP and LP, and do a simplification on what's in the parentheses here. And that would make that JP, then KP from 3 through simplification. And then 4 and 5 make a modus tollens. If JP, then KP, not KP, therefore not JP. 4, 5 modus tollens. And we wanted J, not JZ, so we're going to do a existential generalization here. So we'll add the backward Z with the Z this time, and then tilde JZ. So from 6, existential generalization. And that one's done. Okay? So don't let it fool you if they try to use an X and a Y or an X and a Z in the same thing. Just replace it with the same letter and go ahead and solve it. It's not going to change anything. That's actually the way you should do it. Okay? So I'm going to let you guys try some of these. So for homework, we've got 8.2, and we'll do, I did number 7, so you can do 1 through 6. And about 8 through 10. So basically it's 1 through 10 with the exception of 7, which I've done for you there. So that's going to be your final homework assignment. As always, if you have any questions, let me know. But otherwise, I will be happy to go over those with you in the next video here.